Let's go to page 130 and start with number 141. Okay, you want to evaluate the absolute value of 7 minus 24i over 4 plus 3i. Now, with the absolute value of the fraction, you can separate the top from the bottom. So this will equal the absolute value of 7 minus 24i over absolute value of 4 plus 3i. Okay. Now, absolute value means the hypotenuse of the triangle, and so you just use Pythagorean theorem, or if you recognize this is a special triangle, right? So if you were to sketch this would be 7 minus 24, so it would be 7 negative 24, so this would be a 25. Okay? We can use your Pythagorean theorem. Now for this one is very obvious, right? It's 3, 4, 5 triangle, right? So 3, 4, 5 triangle, and so this will be equal to 5. Okay? So again, you can use Pythagorean theorem, a squared plus b squared equal to c squared. Okay? Now when you use Pythagorean theorem, do not include the I. Okay? I just the direction. Okay? Just like this one over here, right? So this one would be 4, 3. So it would be 4, 3. So it would be a 5. Okay? Again, I is just a direction because this is the imaginary direction and this is the real direction. Okay? Okay, let's go to the next one. Okay, so you're looking for 1 plus I to the 4th power times 2 minus 2I to the 3rd power. So for this one, there's a couple of ways you can do this. One way is just using the algebra. So this would be equal to, so you can factor the 2 from here. So you got 1 plus I to the 4, and you factor the 2 to the 3rd power, so it would be 2 to the 3rd power, and this would be 1 minus I to the 3rd power. So factor the 2 from the parentheses, so it would be 3 power. Next thing is you're going to regroup them. So 2 to the 3rd power is 8, and keep one of these so that you get 1 plus I to the 3rd power and 1 minus I to the 3rd power. Okay, so you want to group the conjugate. And so this becomes 8 times 1 plus I times 1 plus I, 1 minus I, okay, to the 3rd power. So now you can go and multiply the conjugate. So when you multiply conjugate, so it would be 1 minus I times I is negative 1, so it becomes plus 1. And so 1 plus 1 is 2, 2 to the 3 is 8, so you're going to get 8 times 1 plus I times 8. And so when you multiply, you get 64 plus 64i. Okay. Now another way of doing this problem is use you can convert into the Porter form. So you got 1 plus I to the 4, 2 minus 2I to the 3. Okay. So this one, if you to sketch out, this is 1, 1. So it'd be square root of 2, and this would be 45 degrees. So this would be equal to square root of 2 e to the I 45 degrees. Okay. This one, so you got 2 minus 2, so you got 2 negative 2. So this would be 2 square root of 2, and this would be negative 45 degrees. Okay. So this would becomes 2 square root of 2 e to the I of negative 45 degrees to the 3rd power, and this is to the 4th power. Okay, so now you can go and work this out. So square root of 2 to the 4th power will equal to 4, and then this would be e to the, so this one you just exponent of exponent, you multiply, so it would be I to the 180 degrees. Okay, this one when you multiply 2 to the 3rd power is 8, and square root of 2 to the 3rd power is 2 square root of 2. So this gives you 16 square root of 2, e to the I of negative 135 degrees. Okay, so now when you multiply this together, you're going to get 64 square root of 2 e to the, when you multiply, you have to add the exponent. So this and this will give you I of 45 degrees. Okay, so now you're going to convert this back in rectangular. So you draw your triangle. So 45 degrees, right? So that's your 45 degrees. and the radius is 64 square root of 2. So this would be 64 and 64. Okay, so this will equal to, so this will equal to 64. That's this one over here, and this is the I direction, so it would be plus 64I. Okay, and so you get the same answer. Okay, so two different ways to win the problem. Okay, let's go to next one. Okay, it says find the product of the nth root of 1. Okay, so to find the nth root of 1, your equation is x to the n equal to 1. And so that way, when you take the nth root, you get all the nth root of 1. Okay? So here's your, so this is the equation, and then you want to find the product of the nth roots. So go ahead and minus 1 from both sides. So you got x to the n minus 1 equal to 0. And then from your root equation, okay, so because n can be any number, so let's go and look for the pattern. So for the second powers, when n equal to 2, right? So the second degree root equation is x squared minus r1 plus r2 plus r1, r2, right? So here's your product of the roots. For the cube, you got x cubed minus r1 plus r2 plus r3 plus, or plus minus plus something, or you got x over here, x squared, or x squared over here. So this would be x. Okay, so you can 3, 2, 1. So plus minus plus minus r1, r2, r3 equal to 0, and so forth, right? Now you're going to match it up. So notice when n equal to 2, okay, that is this one here. When n equal to 2, you have r1, r2 equal to, match it up equal to -1. Okay? So when n equal to 3, this match with that, and notice the negative match, right? So you're going to get r1, r2, r3 equal to +1. Okay? So notice alternate. So therefore, the product of the roots, with alternates would be -1 to the, so you want to test see which one they match, right? So you start with n. So when n equal to 2, -1 to the 2 will give you positive. So this one does not match. So you just have to +1. Okay? So now you match. So when n equal to 2, so you got -1 to the 2 plus 1 to 3, so it gives you negative. When n equal to 3, this becomes 4, so it's even, and it would become positive. Okay? And so that will be your answer for the number 143. Okay, let's go to the next one. Okay, number 144, you have f of z equal to z plus 1, z over z minus 1. So you're looking for the function of 1991. Okay, so plus I equal to. Now, this is not an exponent. Okay, this is the composite. I'm just going to put z. So this is equal to f of da 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 da. Okay, f of z. Okay, and so this would be 1991 of it. Okay, so it's not exponent. It keeps substituting. Okay. Okay, so to do this, first let's go ahead and since we're looking for this, right? So let's go and look for f. Let's look for the first one. Okay. So when the function is the first order, so you got f of 2 plus I. So use this one, so it would be 2 plus I plus 1 over 2 plus I minus 1. So f of 2 plus I will equal to 3 plus I over 1 plus I. Okay, but you want to simplify this. You don't want to have an I in the bottom. So let's go and multiply by conjugate. So f of 2 plus I will equal to, so it becomes 3 minus 3I plus I minus I squared become plus 1, right? So this would become minus I squared is plus 1. On the bottom, the conjugate will be 1 minus the I squared is negative 1, so this becomes plus 1. So the first order function will equal to 4 minus 2I over 2. So the first order function, okay, the first layer will give you 2 minus I. Okay. Now we're going to do the second one. The second order function of 2 plus I, okay, will equal to f of 2 minus I, right? Because the second one, right? So you substitute this into here, okay. Again, if you don't see that, this, okay, let's do one more step. So f the second order of 2 plus I is equal to f of z, okay, or the first one, or 2 plus I. Okay, so that's what it's equal to. But we already know that the first layer is, this one is here, so this becomes f of 2 minus I, right? This is equal to 2 minus I, okay? Okay, so now we're going to substitute into here. So this is going to equal to, okay, use this function, right? So it'd be 2 minus I plus 1 over 2 minus I minus 1. So now you work it out. So you're going to get, so go ahead and work it out. So you're going to get 3 minus I over 1 minus I. Again, you want to simplify that. So multiply by the conjugate. Okay, so again, so the second order. Okay. Okay, so again, you work it out. So you're going to get 3 plus 3I minus I squared, so it becomes plus 1. On the bottom, you're going to get 1 minus I squared become plus 1. So the second order will equal to 4 plus 2I over 2. So the second order would be 2 plus I equal to, of the 2 plus I will equal to, so reduce, so you get 2 plus I. So double check. Yeah, so second order. So notice that so from here, right? So when n equal to odd, so n equal to odd, it will give you 2 minus I. Okay? When n equal to even, okay? When n equal to even, this will equal to 2 plus I. Okay? And it's just go in a cycle of 2. Okay? So now we go back to over here. So from here, n is 1991. So n is odd. So odd, your answer would be, so therefore this will equal to 2 minus I. Okay. Okay, let's go to the next one. Okay, for how many possible real value of k? Well, 2 plus ki to a 3 power, okay, equal to a real number. Okay, so what happens is when you, so again, if you convert into polar form, this is going to give you, so this is going to become z to the 3 power. So when you multiply out, you're going to get r e to the some kind of degree, okay? So what happens is when you multiply, it will rotate around the circle. Now since this is a third power, it will take 3 parts to complete the cycle. And so only way, so when you divide the circle into 3, okay, that's only one answer right over here that can have a real number, okay? The other two will have an imaginary number, okay? So it's 3, so you take 3 rotations to get back to the original spot. So if I divide a circle into 3, that's only one way that you will have a real number, and it's right over here. Okay? And so therefore answer is 1.